All right, so today we are going to talk about inverse functions. So we're looking at inverse of quadratic functions. If you recall, we've done inverses before, but we did inverse for linear functions, okay? So an inverse function is a function that undoes another function, so think opposites. So we're going to talk about examples, but really we're just going to talk about examples of like inverse operations, okay? So all right, so inverse operations, like opposite operations. So like you have plus and minus. Those are opposite or inverse operations. They undo each other, right? So if you did minus 5 plus 5, they cancel each other out, right? They undo each other. Just like multiplication and division. Okay, so the ones we're going to focus on today, the opposite ones that will undo each other, we are going to focus on if you have like an x squared, the opposite, because for a quadratic function you have an x squared, right? So the opposite of squaring something would be to square root it, okay? So squaring something and then square rooting it, those are opposite functions. They're opposite operations, so they're inverse operations. So those are the ones we're going to be looking at today. So just a refresher on the steps of finding inverse functions. Your equation would look something like this below. Step 1 is just to replace f of x with y, because f of x is equal to y. They mean the same thing, right? So instead of f of x here, we'd replace it with y. Step 2 would be to swap your x and your y. So they would switch places. And step 3, you'd solve for y. Step 4, once you get y by itself, you then replace it with f negative 1 of x, meaning f inverse of x, okay? So f of x is your original function. F to the negative 1 power of x, that is your inverse, okay? All right, so step 1, just replace f of x with y. So all we do is put y here instead. Step 2, swap x and y. So I'm going to swap in x for my y and y in for my x, okay? Step 3, solve for y. So we're working on get y by itself. It's on this right side, so I need to cancel out this plus 1. This is not part of my y. So I'm going to say minus 1. These are not like terms, so it stays as x minus 1 equals y squared. So y is by itself other than that squared, okay? What we're going to do is we are going to take the square root, because square root and square would cancel each other out. And if we do it to one side, we have to do it to the other side, okay? So here's where I need to make a little side note. If you did 3 squared, you would get 9. If you did negative 3 squared, you also get 9, okay? Because 3 squared means 3 times 3, which is 9, and negative 3 squared means negative 3 times negative 3. Negative times a negative also make it a positive 9, right? So what that means is if I took, say I told you y squared equaled 9, right? And then I took the square root of both sides, then that gives me y equals, and we know the square root of 9 is 3, right? So y is 3. But y could have been negative 3 also, okay? Y squared equals 9. So this y could be 3 squared, or this y could be negative 3 squared, right? But when you solve it this way, you're always going to get the positive answer. So what you need to know is that whenever you take the square root, then they're solving it like this. You take the square root of both sides, then y really could equal a positive 3, or it could have been a negative 3. So in this case, when these cancel out, we square rooted this side. Y could either equal a positive or a negative square root of x minus 1. Okay, so you could leave your answer like this, saying it would equal a positive or negative. Or technically we want to do step 4, which is replace it with the inverse, right? equals, I'm gonna write it this way, positive or negative square root of x minus 1. Or you could list out the two answers. Your two answers would be a positive square root of x minus 1 as well as a negative square root of x minus 1. Okay, you have both answers. And I'll show you why. Let's look at them on the graph. So we're finding an inverse function, right? So the inverse of squaring something would be to square root it. Okay, so quadratic functions, this is important, and square root functions are inverses. Right? They are inverse functions. Okay? So let's look at it on the graph. All right, so here I have my original function, the y equals x squared plus 1. This one's graphed, okay? We're saying that they are opposites. So instead of my parabola opening upwards, or sometimes they open downwards, these are gonna open to the right or to the left. Okay, so let's look. If I turn this first one on, square root of x minus 1, it's only half, right? That's because the inverse, you need both halves, right? So now you can see that they are opposites of each other, okay? And one way you can test is to type in the equation y equals x, okay? The equation y equals x, what it does is it's gonna go diagonally through the middle so that each function is a reflection of the other one, right? So if you were to turn it like this, you can kind of see the mirrored effect, right? Here's your mirror in the middle, and both functions reflect across onto the other one, okay? Another thing you can notice, if let's just take this second one and find its vertex, okay? The vertex of these two is 1, 0. So what do you think the opposite would be, right? We switched our x and y's, right? So if you were to switch the x and y's of your point, you would get 0, 1, right? Your x and y swapped places for your points as well, okay? So what that means, another important thing you want to know, is that so your x's and y's swap, your x values are your domain, your y values are your range. So domain and range swap, okay? So the domain of this function becomes the range of these functions. The range of this function becomes the domain of these functions, right? They switch places, okay? Couple more examples. So we're gonna start by going through our steps. Step 1, we're gonna say y equals negative x squared plus 5. Step 2, we're gonna switch our x and our y only. Step 3 would be solve for y, okay? So I would need to subtract the 5 from both sides to cancel it out on the right side. And then on the left side, this just stays as x minus 5 because they are not like terms. Okay, we want y squared by itself. We have a negative in front, right? So it's kind of like you have a negative 1 being multiplied in front of your y squared. So what we're going to do is we're going to divide by a negative 1, because dividing any number by 1 doesn't actually change that number, right? But if you divide by a negative 1, it's going to change the sign. So this 2 negatives would cancel out, leaving us a positive y squared. And then we also had to divide whatever we do to this side, we have to do the other side. So we had to divide this side by negative 1. If you're looking right here, positive x divided by a negative, positive and negative would make that a negative x. And then here, negative 5 divided by negative 1, the two negatives would cancel to make it a positive 5. okay? So now we have negative x plus 5 equals y squared. And to cancel out our y squared, we want to take the square roots. And if I square root one side, I've got to square root the other side. So I get y equals, or we can say the inverse, negative 1 of x, equals a positive or negative square root of negative x plus 5. Okay. The only thing I did here is, yes, this would cancel out to leave you just y. Well, instead of y, we would replace it to show that it's the inverse by doing f to the negative 1. That shows or means inverse function, okay? And we have plus or minus, which means we have the inverse function equals square root of x, negative x plus 5. And then we also have f inverse of x equals a negative square root of negative x plus 5. We have both these answers, the positive and the negative version. Okay, let's do one more example. Alright, so we're going to start with step 1. We're going to put y equals x squared minus 8. Step 2, switch your x and your y. And then step 3, solve for y. So I'd add 8 to both sides. We get x plus 8 equals y squared. There's not a negative in front, so I don't have to divide by negative 1. Only divide by a negative 1 if I have a negative y squared. Then I would divide by negative 1, okay? If you just have y squared, you're good. That's what you want, okay? So then we take the square root of both sides. You'll get y equals the square root of x plus 8 plus or minus positive or negative, and then we have the inverse function of x equals a positive or negative x plus 8. Remember, you can leave it like this, or you could list them both out. A positive square root of x plus 8 and then a negative square root of x